Okay, let's try and prove this fact in two ways. So let's see if we can do this. Okay, so we're saying that we got a set A, and I guess we're going to say that it's finite. This means that the number of elements in the set A is n. We want to prove that the power sets have 2 to the n element, that the power set has 2 to the n elements. So basically it's saying that if you have a set with, let's say, I don't know, 2 elements, or let's say 3 for the sake of arguing, here's a set A, right? We want to show that then there's 2 to the 3 or 8 subsets, right? So let's list all the subsets we got here. So the subsets are going to be the empty set, the set 1, the set of singletons, the set 2, the set 3, then all the 2 element sets, 1, 2, 1, 3, 2, 3, and then the set of 3 elements, which is the whole set. And this here is now 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets. Now we want to prove this in general. So let's say the set has n elements, right? Consider how many possible subsets of A there are. Okay, for any subset, for any B contained in A, right, either B contains let's say A1, the first element in A, contains A1 or does not. So if I'm trying to see how many unique B, so if we want to see how many possible subsets, how many possible B there are, then for each AI contained in A, AI is contained in B, or AI is not contained in B. And that's 2 choices for each element inside A, which gives 2 to the n possible subsets B. Now that's one proof. Another proof is a proof by induction. So base case, if A is equal to the empty set, then the power set of A is equal to the set of the empty set. And the power set of A has exactly 1 element. So this is, if the order of A is 0, then the order of the power sets is 2 to the 0, or 1. Now let's do the inductive step. If, right, a set has, let's say, k elements, so k, then the power sets, there's 2 to the k subsets, and then let's consider B to have k plus 1 elements, right? Then, right, or let's say I add 1 more element to A. Let's say A has k plus 1 elements. I add 1 more element to A. Now the whole thing is that this is going to double the number of subsets. Why? This doubles the number of subsets because you have some number of subsets from here, right? You have 2 to the k. So here's 2 to the k subsets, let's say, I don't know, A1, A2, so forth, A3, and there's 2 to the k of them, A2 to the k, right? Subsets. These are subsets. Now, you double the number of subsets because for each one of these, you have another element to add. So you're going to get an A1 prime, right? You're going to get an A2 prime when you add this one more element. And then this doubles. So you're going to get that the P of A, the order, is going to be equal to 2 to the K times 2. And then you're going to get the power sets. There's 2 to the K plus 1. And then there's this shows the inductive step, and then you're done.